Define a lambda expression that raises an exception. How can I write a lambda expression that's equivalent to? The following is not allowed.
There is more than one way to skin a python. Lambdas accept statements. Since raise x is a statement, you could write a general-purpose raiser. But if your goal is to avoid a def, this obviously doesn't cut it. It does, however, allow you to conditionally raise exceptions, for example. Alternatively, you can raise an exception without defining a named function. All you need is a strong stomach and 2.x for the given code, and a Python 3 strong stomach solution. Thanks at Warren Spencer for pointing out a very simple answer if you don't care which exception is raised, y equals lambda column 1 0.
How about
I'd like to give an explanation of the update 3 of the answer provided by Marcelo Cantos. Explanation. Lambda column 0 is an instance of the built-ins.function class. Type lambda column 0 is the built-ins.function class. Lambda column 0 code underscore is a code object. A code object is an object which holds the compiled bytecode among other things. It is defined here in Python, this URL. Its methods are implemented here, this URL. We can run the help on the code object. Type lambda column 0 code underscore is the code class. So when we say we are calling the constructor of the code object with the following arguments. varnames equals x, filename equals, name equals, firstlineno equals 1, notab equals b. You can read about what the arguments mean in the definition of the Piketty object, this URL. The value of 67 for the flags argument is, for example, co_optimized, co_new locals, co_no free. The most important argument is the code string, which contains instruction opcodes. Let's see what they mean. The documentation of opcodes can be found here, this URL. The first byte is the opcode for load_fast, the second byte is its argument, i.e. 0. So we push the reference to x onto the stack. The varnames is a list of strings containing only x. We will push the only argument of the function we are defining to the stack. The next byte is the opcode for raise_varargs, and the next byte is its argument, i.e. 1. The toes is the top of stack. Since we push the first argument, x, of our function to the stack and arg is 1, we will raise the x if it is an exception instance or make an instance of x and raise it otherwise. The last byte, i.e. 0, is not used. It is not a valid opcode. It might as well not be there. Going back to code snippet, we are initializing. We called the constructor of the code object. We pass the code object and an empty dictionary to the constructor of a function object. Let's call help on a function object to see what the arguments mean. We then call the constructed function passing an exception instance as an argument. Consequently, we called a lambda function which raises an exception. Let's run the snippet and see that it indeed works as intended. Improvements. We saw that the last byte of the bytecode is useless. Let's not clutter this complicated expression needlessly. Let's remove that byte. Also, if we want to golf a little, we could omit the instantiation of exception and instead pass the exception class as an argument. Those changes would result in the following code. When we run it, we will get the same result as before. It's just shorter.
Actually, there is a way, but it's very contrived. You can create a code object using the compile built-in function. This allows you to use the raise statement, or any other statement, for that matter, but it raises another challenge: executing the code object. The usual way would be to use the exec statement, but that leads you back to the original problem, namely that you can't execute statements in a lambda, or an eval, for that matter. The solution is a hack. Callables like the result of a lambda statement all have an attribute _code_, which can actually be replaced. So, if you create a callable and replace its _code_ value with a code object from above, you get something that can be evaluated without using statements. Achieving all this, though, results in very obscure code. The compile call creates a code object that raises the exception. The lambda column 0 returns a callable that does nothing but return the value 0. This is used to execute the above code object later.
The lambda x, y, z creates a function that calls the _set_attr_ method of the first argument with the remaining arguments, and returns the first argument.
This is necessary, because _set_attr_ itself returns none.
The map call takes the result of lambda column 0, and using the lambda x, y, z replaces its _code_ object with the result of the compile call. The result of this map operation is a list with one entry, the one returned by lambda x, y, z, which is why we need this lambda. If we would use _set_attr_ right away, we would lose the reference to the lambda column 0 object.
Finally, the first, and only, element of the list returned by the map call is executed, resulting in the code object being called, ultimately raising the desired exception. It works, tested in Python 2.6, but it's definitely not pretty. One last note: if you have access to the types module, which would require to use the import statement before your eval, then you can shorten this code down a bit. Using types.functionType, you can create a function that will execute the given code object, so you won't need the hack of creating a dummy function with lambda column 0 and replacing the value of its _code_ attribute.
方，不是 lambda 随后自己的叙